Hello, my name is Andrew Silberman. I'm the Director of Marketing here at Zenity, and I'm joined by Ofer Chacham, Senior Software Engineer. We're here today to talk about Salesforce, particularly around oversharing apps and flows that can be easily created in the Salesforce platform. But first, some context. In February of 2024, Varonis researchers disclosed that several government agencies and private sector companies had customized or added features to their Salesforce Apex code that leak data, allow for data corruption, and allow for attackers to disrupt business functions. Impacted data included the usual suspects like phone numbers, addresses, social security numbers, and username and password combinations. This data leakage is happening because users can create their own apps, flows, and custom code while configuring it to run in a system context, which provides access to all data. I'll now pass it over to Ofer to show you what this means and how it looks.
Great. Thank you, Andrew. Yes, this is a very interesting problem that was disclosed, and one that might have far-reaching impact if not dealt with swiftly. In this portion of the video, I'm going to show two scenarios that demonstrate how easy it is to build app components that leak data. The first scenario is mentioned in Varonis disclosure using Apex code that is running in system context. The second one is a new one that uses a flow that is built using Salesforce low-code development platform that also run in a system context. Running in a system context in Salesforce means having access to all organization data, ignoring the actual end user permissions. For the purposes of my demonstration, I have built a Lightning application that will highlight just how easy it is to equip it with components that expose data to users that don't need it for their jobs. The app uses the contract CRM object that is defined as private object in the organization, meaning that users are not permitted to read contract records that they don't own. To highlight the differences in what a standard user should see versus someone in an admin type role, I will now share my screen. Two windows are open of the same contracts management Lightning app. In one window, I am logged in with a system administrator that is permitted to read all data. In the other window, I am logged in with a user that is assigned with a minimum access profile that is actually not permitted to see any contract records. On the first page of the app, I use a standard component available in the Lightning App Builder called List View. It's basically show a list of records of the contract objects. This component respects the user permission, so we can see that while the administrator can see contract records, the standard user cannot see them because it's not permitted to. On the second page, I will demonstrate a scenario that was disclosed by Varonis. Let's first see the code of two Apex classes. As you can see, the code is very simple. Using a basic SOQL query to read contract records, the only difference between the two classes is in the class definition. While the first class is using the with sharing clause, the second class is using without sharing clause. In order to show the data that it retrieved by these Apex classes in the app, I use two very simple custom Lightning web components that display this data in a list, one for each Apex class. Now let's see the second page. The admin is being able to see contracts in the two components as expected. The user is being able to see all contract records in the component that use the without sharing clause, despite the fact that it is not permitted to see any contract records. Now, while one might think, based on without sharing phrasing, that the meaning is not sharing records with unpermitted users, the real meaning is without sharing rules. These rules determine what records are shared with what users. They are based on organization-wide object access, organization roles hierarchy, and custom sharing rules. Without sharing means to bypass all of this and let all users see all data. By default, if no sharing clause is being used in the Apex class definition, the class inherits sharing configuration from its caller. Now, on the third page, I'm going to demonstrate a very similar scenario. The difference is that instead of using an Apex class, it uses a flow that runs in a system context. Let's first see the flow definition inside the flow builder. As you can see, the flow is very simple. It has only two steps. The first one is using the action of get records in order to retrieve contracts. The second one is a screen step that is using the previous step records in order to show them inside a list inside a screen. Now let's see the settings of the flow. As you can see, this flow is configured to run in a system context without sharing, and we also can see that it says that it can access all data. So on the third page, we can see that, of course, the admin can see the two contracts, but the user is also being able to see the two contract records despite the fact that is not permitted to see any. From a security perspective, this is a huge red flag that shows that A, business user can easily create flows and Apex classes that are unintentionally leaking data to unauthorized users. And B, secure teams are lacking the tools needed to identify the applications and automations that are created in a system context classification that can easily lead to data leakage.
Awesome. Thanks, Ofer. So here at Zenity, we're helping customers deal with this issue with continuous visibility and inventory of all apps, automations, and flows created within Salesforce, assessing them for security violations like the ones that Ofer just showed, and layering in autonomous governance with playbooks and policies. For more information on how we help our customers do this, check us out at zenity.io.